Should we start? Okay. Okay. So, before I get to the title of that, my talk is a forward-looking statement, which is standard for all our talks. Anyway, the title of our talk is delivering sub-second latency for operational workloads on Databricks, and we have been working on this for a couple of years, and today we are showcasing some of the aspects that we have done so far. So the talk is divided into four distinct parts. First, I will give you a streaming overview and adoption of it at Databricks, and followed by what type of pod use cases that Databricks pipelines run. Then we introduce real-time mode, Spark real-time mode. What is it, and what are the big ideas there? And also we give a bunch of use cases that we tested with customers, and how much latency that they were experiencing before in the previous system versus how much latency that they are getting in the RTM system. So this that will be depicted on the final customer validation section. So let me give a streaming overview. So the world operates in real time. So what about the decisions? In fact, like the speed of business has increased nowadays, but even then data is analyzed at every day or every week, but that is not competitive enough. So you need to do it right now and in real time. So organizations are also started having more streaming data every year. This information is most valuable when it's used in real time. So the value of the data when you acquire the data right away is the highest, and it exponentially decays as the time goes on. So the moment data is generated, if you generate insights and use the data, that has the highest value. So with the new opportunities for real-time data, so since every organization generates a vast amount of real-time data, for example, a bank generates a lot of transaction records from point of sale and airline reservations and all the call center records. And third-party data also is provided by weather, news feeds, and market data, and real-time traffic data. And then the interactions, when you click on interactions on the web and the mobile phones, those clicks are captured as web clicks, and the social posts, social media posts, emails, and instant messaging. Similarly, you have the IoT, broad IoT sort of industry where sensors are sending data always. So that includes sensors in the trees that they are monitoring, and in an environment that they are monitoring in, geolocation tag, machine logs, which is generated from machines, computers that are doing your applications or even microservices. Those are machine logs, and mobile devices also generate logs. So this generates a lot of opportunities for real time. In terms of applications, what are the interesting applications that you can write? That includes fraud detection and personalized offers when you're looking at the click data, and vaccine distributions when you want to do real time, and also in-game analytics, connected cars, and vehicle maintenance. So this is a bunch of applications that you can do. Now, when you generate all this real-time data, how are you going to process it? So stream processing essentially captures the data from databases or CDC apps or CDC or apps or collection agents, where all the data that I mentioned in the earlier slide is collected, and it is staged in two different distinct systems. One is S3 or buckets, where you realize the data in terms of S3 files, whereas another one is where the data lands is in a buffer called Kafka or Pulsar, those kind of message bus systems. And from there, stream processing engine takes the data, processes it, and aggregates it into whatever the aggregation that needed, and writes it back into AS3 systems or even Kafka or whatever it is, and which in turn serves analytical applications for dashboarding purposes, or it can be used for operational applications. So operational applications is what we will be talking today. So streaming with Spark. So we have advanced stream processing in Spark on many accounts. So the one key thing that you have to note is Spark is a unified engine that processes both per batch and streaming, because the API is compatible for both. And it's also fault tolerant, because we use a microbatch model in the Apache Spark, and when the microbatch fails, we roll back the microbatch to the last processing checkpointing, which is essentially the end of the previous microbatch. And each microbatch also is planned, which means all the data that is going into each microbatch is already known. And since it's already known, when you replay the batch, you get the same behavior of the failed batch. So which is fault tolerance is good. And also the advantage of fault tolerance is, since we are doing a microbatch model, which we call it as a pessimistic failure model. So we can do that in what you call Amazon chip instances as well, where there is a lot of failures. So, but when the failure occurs, since it's at the microbatch level, we can rewind it and pick up the new instance as well. So streaming in Spark also has low latency, because in the microbatch low latency in the few second range, but that considers low latency for a lot of applications, as you can see, and is also cost effective. You can trade off the latency and the cost by dialing down on the slots, executed slots. So if the slots are a lot of slots are available, then all the slots can run simultaneously, which means your latency will be low. And the low number of slots is there, what are the tasks that you can schedule will get scheduled, but if there are tasks that are waiting for it, then latency will increase. So it provides a nice trade-off between cost and how much latency you want to get. And easy to use, and all the powerful operators like stream static join, stream join, and all the various things are available. And advanced stateful processing also is included. So where you can do a newly released an API called transform with state, which allows you to do a stateful processing in Apache Spark. And increasing, so I've been amazed at the growth of streaming in Databricks. When I joined Databricks, we were doing around 10 or 15 million jobs. So now it has gone up to more than 30 million. So which is growing at 60% a job over a year. So this is mind-boggling, especially considering the fact that the number of jobs that are running is so huge. And streaming customers in every industries, ranging from software tech, retail, media and entertainment, and financial services, public sector, transportation, and healthcare and life sciences. So streaming is applied across the board. There's not only one industry is using where they realize real time, but it's applied across all over the place. So what are the streaming use cases and a broad categories and a broad consensus? So I divide the streaming workload into three different categories. One is analytical workloads, another one is machine learning workloads, another one is operational workloads. Traditionally, database has been good at running the analytical workloads and machine learning using the microbatch formats. So what is the analytical workload does? Analytical workloads analyze the streaming data for instant insights and faster decisions. So once the data comes in, it's aggregated or on an hourly basis or a minute basis, whatever the aggregation needs to be there, and stored in Delta Lake, and then those tables can be queried to power dashboards that can generate insights on a hourly basis of product sales or whatever it is. Machine learning train models on the freshest data using Spark and score that model in real time. That also can be used in Spark. So if you look at the flow of data flow of these use cases, the data lands up in Kafka or Kinesis or some message buses, or even a cloud storage like S3. The data is ingested into Delta Lake using streaming itself, and further computations are done at using streaming jobs that take the data from the Delta Lake, compute it, and store it back into Delta Lake itself. So once, so that is where the medallion architecture that you are aware of it, right? The bronze table, silver table, and gold table comes into play. And once those tables are returned back into Delta using streaming jobs, then you can serve the analytics out of it. So which you can power the dashboards, or you can even score the model in real time in machine learning. So this satisfies two use cases, analytical use cases and machine learning use cases. Now let us look at operational use cases. How many active logins do I have per streaming account? And what are my operators of an industrial equipment? Do I need to send a promotion to a user struggling to purchase who is browsing currently? So business critical operational use cases like these require consistently low latency, even though the definition of low latency varies from customer to customer, but we will give a range. So data flow on these on these operational workloads indicate that the data available in Kafka has to be processed, Kafka, Ramasamy, Kinesis, or any message store, process the data, and you have to write it back to some of these message stores or operational databases like OLTP or DynamoDB. The reason why we have to do that is if you write it into Delta, Delta is based on S3, and S3 has a lot of latency built in, because each write into S3 can take around minimum 1 second, because 500 milliseconds that you write. One is to write the log as well as write the actual data. So that's why the low latency operational use cases go from fast message buses to fast stores that include message buses themselves or OLTP databases or DynamoDBs or key value stores. And Databricks has been shown to the best place for streaming and ETL and ingestion. Having conquered the analytical and machine learning space, what can you do about the low latency? So we have been doing the microbatch mode, which is spanning on streaming and ingestion. And what are you going to do about the operational use cases? That's it. We're introducing the real-time mode. Jerry will talk about the real-time mode.
Sounds good. Thank you, Karthik. I think one thing Karthik failed to mention is introducing us. That is Karthik. I am Jerry. Hopefully that's obvious. Thanks, everyone. We are both from Databricks, and we both have worked in the area of stream processing for a very long time. We've virtually worked on every stream processing system, every messaging system out there. And that's why we are super excited to really introduce what Databricks is doing next in this space. What our team, the Stream Engine team, is doing next. Real-time mode. I think some of you were at my talk yesterday where we went on a deep dive into exactly how it works. The emphasis of this talk is a little different. We're going to be mostly going over the use cases that some of our customers at Databricks have been using real-time mode for. But I'll provide an overview of kind of how it works so it becomes a little bit more concrete and it's not just vaporware and we're just inventing a bunch of stuff here. So I'll just go over a little bit kind of how it works. And also, we talked about this yesterday. Real-time mode, this is going to be open source. So you guys will see the code in open source. So that's going to be out there as well, and we're going to contribute basically this feature to open source structured streaming as well. So let me first kind of talk about what is real-time mode, right? So the real goal of real-time mode can be kind of summarized in one sentence. The top goal is real mode provides latency in the order of milliseconds, end-to-end processing latency in the order of milliseconds. And one of the other special things that we've designed is you can simply flip a switch and to basically enable real-time mode. You don't need to change any code. It should just be simply flipping a switch and you can basically enable real-time mode in your existing structured streaming queries. And if you were there for my demo yesterday, for my talk yesterday, I gave a demo where basically I did that. I had structured streaming query. I changed basically the trigger, if you're familiar with structured streaming. I changed the config. And then immediately, the latencies I was getting from the query, the pipeline, turned from seconds to double-digit milliseconds. And that was really cool. And another thing to say is, at Databricks, for real-time mode, we're currently in gated public preview. So basically, we are actively working with customers and basically supporting them in production. Let's look at some numbers. These are actually old numbers that we ran about a year ago. The numbers actually now are a lot better. We've ran the numbers again. Michael Armbrust's keynote tomorrow, he will actually show the more latest numbers, and they're actually a bit better than this. But these numbers still kind of prove the point of real-time mode, that we're basically able to significantly lower the latency over the existing execution modes. What I mean by existing execution modes, if you're familiar with structured streaming, we're talking about trigger processing time. That's basically the kind of mode that's used by default, and you would get the lowest latency, right? Trigger available now, that's not really a latency discussion there. That's more of a throughput kind of mode, or kind of periodically running a incremental batch job. But as you can see, we're basically achieving 2 orders of magnitude lower in latency, from basically tens of seconds to low triple-digit milliseconds to double-digit milliseconds in latency, right? So it's a significantly lower in terms of latency when you use real-time mode. It's not just low latency, it's also scalable. We are running, and we've been running basically also testing, benchmarking real-time mode at scale. And also our customers that we've been working with have been basically testing it with their real production workloads. And here we demonstrate that real-time mode is scalable. It can scale. It can process not just data in low latency, but also high volumes of data as well. And going back to kind of what Karthik discussed in this slide, right? We have this latency spectrum. The existing execution modes, right? We call it micro-batch mode, but I don't even really like that term. It's, let's just say existing execution modes, right? Databricks pretty much have is doing very well, or I would like to say, I'm a little biased, but we pretty much have won kind of that area in terms of streaming ingestion and ETL into basically the lakehouse. The thing that we need to tackle is these lower latency use cases, right? These ultra low latency use cases that are on the rise now, right? As Karthik explained, everything becomes more and more real time, right? If you will. And everybody wants results, things done quicker and quicker, right? So this is where basically real-time mode serves, basically its purpose to serve those kind of workloads in that basically area with those latency targets. So let me kind of talk about how real-time mode works. The big ideas are basically, running longer batches, right? There's a lot of overhead in the existing kind of, how we run, micro batches and the existing execution modes. So basically, let's run longer batches, tasks are more long-lived, and let's also do concurrent stage execution, right? Where basically all stages run at the same time. So here's basically kind of a depiction of that. Before, kind of when we were running in processing time or the current kind of execution modes, batches are typically basically based off of how much data is available at that moment. We're going to process it, and then we're basically going to check for the next available data, process it. The batch sizes or batch ranges are mostly based off of basically data size, right? And there's a lot of basically overheads. We discussed some of that in my talk I gave yesterday with my coworker Celine. So we really, after realizing these things, we basically thought about it differently, right? Let's redesign this or kind of rewrite the mechanism so that batches are actually not in terms of how much data, but in terms of time, that they execute for a fixed amount of time, regardless if there's data or not. Basically, this batch and all of the tasks, the whole basically DAG of your query will be running so that when data comes in, we are able to process it super fast. So one of the other things we've done here is instead of basically cutting or checkpointing the range of the batch before we actually process it. If that's a detail of how structured streaming works. Now we basically, since we're running on fixed length durations for batches, we will run the batch, say, for 5 minutes, right? Executing, all the tuples, processing all the messages that come in. Wherever we've processed up to, we will checkpoint, and then we will start again. And then we would run for another, set amount of time, and then we will checkpoint, so on and so forth. The next thing I talked about is running all the stages concurrently, right? Concurrent scheduling. So currently, in structured streaming, one stage, if you think about your query, right, it can be multiple stages, right? Your map stage, your reduce stage, or even further reduced stages that you may have, right? Currently, in Spark, Spark and in structured streaming, stages run sequentially, one stage at a time. They're clearly kind of not so conducive to latency if you think about it. So one of the other things we've done is let's run all the stages concurrently, right? So basically, mappers can send data to reducers immediately once they've done processed it. So if you realize, if we do this, what else is needed? The other thing is needed is a new type of shuffle. Because the current shuffle, the sort merge-based shuffle that is used in batch queries and also in streaming queries in Spark will not work, right? What we really need is a push-based shuffle. I know if you're familiar with Spark, there's already a push-based shuffle, but this is different. This is more point-to-point. Mappers will send basically data directly downstream to reducers. Upstream will send downstream data immediately when it's basically available. So that's also basically how we can achieve low latency as well, is concurrent stages, and also with the streaming shuffle that can push data out immediately. So now, let's talk about kind of validations, right? The use cases some of our customers have used real-time mode for, right? And what have they been doing? Of course, I can't really say the exact names of these customers, but we can talk about their use cases and kind of the general area where they worked in, where they're part of. So the first use case we can talk about is a use case by an OTT provider. And what they want to do is track new devices, right? Pretty common cases. So they want to see what is the first device from basically a user that have come in. They want to keep basically track of that. So they have a pipeline that uses that has that data coming in from Kinesis, and then we're basically reading that with a query running in real-time mode, and also it uses the operator transform of state to keep track of what is the first device this user basically has used to watch the content of this OTT provider, right? First, basically tracking new devices, tracking basically the first device seen for this user. And then they're writing the results to Redis, where basically they can serve those results as well. So that's basically one of the use cases that we worked with this customer to implement. And here are some numbers that they've basically ran and gave to us. MBM is the microbatch mode, the existing execution mode, processing time, basically the query running and processing time trigger. And the yellow there, the bars, if you can even see, it's so low. There's a huge contrast, right? Is running the query running in real-time mode, right? And you can see it's a huge difference. Sorry, hopefully the numbers are clear, but it's a huge difference, right? Orders of magnitude difference in basically latency. And they're really basically happy with that. Another use case here, use case number 2, is with a very large bank that, if I say the name, everybody would know. But their use case, very standard, fraud detection of credit card transactions, right? Not so hard to imagine. So they wanted to obviously test this with real-time mode because, as Karthik explained, for things like that, latency really matters, right? You don't want to catch, these fraudulent, transactions when it's already over, right? You want to catch it as soon as you can. So they kind of POC'd on 2 kind of different variants of this on real-time mode. One is, reading from Kinesis using transform of state, and then they use this operator for each to write the data to DynamoDB. right? They wanted to basically serve the results in a DynamoDB, but they also tried something else, right? They basically the same workload, same workflow, but they wrote the results to Lakebase, right? I think that was also kind of announced in the keynote today. Lakebase is basically a Postgres offering at Databricks, right? And we have some results here. For basically using the existing execution modes on DynamoDB, the latency was in the order of tens of seconds, right? 14 seconds, tens of seconds. With real-time mode on DynamoDB, we're able to lower that, quite a bit. But if you're using Lakebase, the latency can even be further decreased, right? And now we're talking about P99s and 151 milliseconds, right? That's what we got. And that's really cool. So here's another use case. The customer here is a large travel site, and what do they want to do? They want to basically keep track of the last 10 searches of a user, basically on both their website version and also the mobile version of their service. So they just want to keep the last 10 searches, so when basically the customer comes back, they will know what the last 10 basically things that they've searched, right? So they have this pipeline where they have two sources, from Kafka, which one is data from their mobile app and one from their website. They're unioning it, and they're using for each to write to the results to basically get results from the current results from Aerospike, and also write the new results to Aerospike. And they're using basically Aerospike to serve basically their results. And same story with the latency. With the existing execution modes, they're able to only get latency in the order of seconds. With real time, they're able to decrease that even further. And there was also a concern with maybe cost with real time. So there are basically also we've created tools or strategies that they can oversubscribe cores, or in the case of say reading from Kafka, single task or single cores can read from multiple Kafka partitions to basically lower the cost of running their query in real-time mode as well. But yeah, those those are the numbers for basically that use case. And we have another use case. This is from a large food delivery service. So basically, what they wanted to do was update their feature store, right? Another basically common use case for that requires low latency. So this is also basically in their pipeline. They're reading from Kafka. They're using for each to read and write to Redis. Redis is basically their feature store. They're using that as their feature store. They're basically reading and writing and updating that. And they're also basically then sending out some results downstream to Kafka. And this was an interesting case. The reason why was this customer was actually pretty, what is the right term here, like brave, maybe? Because before, they were using this mode called continuous mode. If people are familiar with that, this was introduced in 2017. And it was like a kind of a toy experimental mode that, the goals are similar to RTM, but it wasn't really fully fleshed out. Like it supported basically stateless queries and it offered low latency. And it was never really supported by Databricks. It was just something like, this is something we could do in the future, but never was really fleshed out. But they decided to go production with it. And, that's great for them. But like when they heard that, we have real-time mode and we're going to support it, seriously, and we have a path forward to the future for both stateless, stateful, and everything, like basically going to be full functioned, they were really excited to get onto this new mode, real-time mode. And it turns out they actually get better latency, a little better, but I think the most benefit for them is like they're no longer on this experimental thing that is not really getting any updates or no one's really supporting it. They're moved over to real-time mode, which Databricks is seriously committed on. So there is another use case for basically a mid-sized financial product company. So what they wanted to do is they didn't give us a whole lot of information on this one, but what they wanted to do is use real-time mode to transform data into the required format downstream for fraud detection. They didn't do the fraud detection in basically the query itself, but they wanted to basically get the data into the correct format so they can do fraud detection downstream. So, another fraud detection use case was a Kafka to a UDF to transform their data, custom code that they've written, and also basically write to the sink, a Kafka sink as well. Here, I don't think we had a comparison with the existing execution modes, but we had some numbers with when they ran it for real-time mode. So, those are the numbers. Pretty low, P99, 50 milliseconds, right? That's the latencies they were achieving. Karthik, there was another, I wanted to make sure I cover this. There was another use case where they did a Flink comparison, right? Which one was that? First one. So I wanted to make sure I want to talk about this because it's actually really cool. Remember, those are the numbers we got, right? P99s for basically RTM was 152 milliseconds. This customer, device firsting, this OTT customer, right? They actually ran this on Flink. And we get a lot of questions about, well, RTM versus Flink, right? This was a case where our latency actually came in better than Flink. Flink the customer told us about, they were hitting latencies about 200 to 300 milliseconds. And real-time mode was able to bring that down lower to 152. So that was, another basically validation point for real-time mode, as well, and we were super excited to hear that story. So some of the other use cases that, we've heard customers, been talking to customers about, one is, kind of a multiplexing use case, partitioning a stream into, multiple streams, right? Based off of, whatever logic they want to split a single data stream into multiple streams. So, downstream, there can be, different types of consumers downstream. Another is data anonymization. And another is data encryption, of incoming events. And then another, I think, is quite kind of popular is online model serving. They want to do, online inference and, basically serve results in, real time and low latency. So I guess, hopefully you guys have this question. How do we get started with real-time mode, right? How do I, start testing it? Is this guy that's telling you all this stuff, is it real? Is it not real, right? You guys want to hopefully get, try it out for yourself. How do I get started? One, let me first go over kind of what is supported, right? Like I mentioned, it's currently in public preview. It's available on DBR 16.4. The environments we're supporting it is Classic, basically kind of no isolation, and DLT Classic as well. The languages we're supporting, Scala and Python. Execution modes, update mode currently is what we're supporting. Sources, all of basically the common message buses, Kafka, MSK, Event Hub, and Kinesis as well. And the sinks we support are basically Kafka and the for each sink that I mentioned before. And if you want to kind of start testing real-time mode, I would suggest you reach out to your account team, and then they can provide basically an onboarding guide that we can give you, and you can basically start using real-time mode or testing it out yourself immediately. Or you can send us an email. I'll put our email addresses here. Feel free to contact us, and we can basically get you started on that path as well. Or you just want to tell us your use case, discuss what you kind of your thoughts are, or should I use real-time mode for this? Feel free to basically send Karthik and I a message. Yep, that's all I have. Thank you for listening in, and I guess we can maybe do some Q&A. Thank you, everyone.